This is the lecture for lesson 14. The first part of this lecture will be about relations and functions, determining if a relationship is a function, identifying domain and range, determine whether a relation represents a function visually, as well as using the vertical line test. We are first going to determine if a relation is a function. So we have to know what a function actually is, or what the definition of it is. So a function is a relation where each x has only one y value. So for every x, there is exactly or only one y value. The biggest thing is we don't want to see y squareds. Y squareds represents not a function. And I'll talk about that when we see one. So looking at A, we have 3x plus y equals 9. Y is not squared. There's a single x, a single y. So this is, yes, a function. For B, we have y squared equals 3x squared minus 2. Now, I mentioned here that when you have a y squared, it's not going to be a function. So here's why. If I bring this down here and I let x equal 1, well, I would have y squared equals 3 times 1 squared minus 2. Y squared equals, well, 3 times 1 squared is 3 minus 2. Y squared equals 1. And to solve for y, then, I would square root both sides, and I could get positive 1 or negative 1. So what it's telling me is if I have an x of 1, my y has two potential options, 1 or negative 1, which then is not true with the definition of a function, where each x has only one y value. This x has two y values. That's why this is not a function. The same thing will happen with C. Y squared equals negative 5x minus 4. In this case, if I were to use, I want to say negative 1, y squared equals negative 5 times negative 1 minus 4. Well, negative 1 times negative 5 is positive 5 minus 4 gets me that y squared equals 1 again, just like over here, where I'm going to get those two answers, positive or negative 1. So again, in this case, if x is negative 1, I've got positive 1 or negative 1 as a y value. So that does not count as a function. It is okay to have x squared here. Y equals 3x squared plus 9. That is, yes, a function. The problem is we cannot have more than one y value for every x. Another way we may see a relation is with pairs of points. And we can then talk about if they are functions, as well as talking about domain and range. So domain is all of your x values that work for the function, and the range is all of the y values. So when you're given points like this, domain and range are actually very, very simple. You are just going to list D for domain, R for range, use some curly braces, and list the x values in numeric order. So the smallest x value I have is 2. Then I have 4, 5, 8, and 11. And I'm going to do the same thing with the range values. I'm going to list them in numeric order. So the smallest is negative 2, then is 0, then 1, 3, and 7. And you'll end with curly braces when you're done. Okay, next one has 4 pairs of points. Again, find the domain and range. So I'll put a capital D, a capital R, and I'll open my curly braces. And I'm going to look for the smallest x. So I have 1, 1 again, so I don't need to rewrite it. Once I write that number, we're good. There's a 3 and a 6. Then for a range, I'm going to look at my y values. The smallest is -3, then 0, then 2, then 5. And we can do the same thing with the last problem, number 5, domain and range. So smallest is -8, then -4, -1, 0, and 1. And the y values, the smallest, we've got 1, 2, 3, 4, and then 7. So now we're going to look at these pairs of points and determine whether our relationship is a function. So we already mentioned that every x must have only one y. So for each x and y pair, they have to be unique. I cannot have, say, this x number and 1 paired with that same x number and 7, because that means that x has more than one y value, which is not true of a function. So I'm going to look at all my x values. 4 is paired with 5, 6 is paired with 7, 8 is paired with 8. They are all unique x values, each paired with a single y. So yes, we have a function. When I look at b, the x value of 5 is paired with 6, but the x value of 5 is also paired with 7. So no, we can't do that because each x can only have one y. So the x value of 5 cannot have two answers for y. So no, b is not a function. Another way to determine if we have a function is by looking at the graph and doing what is called the vertical line test. What you're going to do is you're going to draw a vertical line or multiple vertical lines, whether you want to actually draw them or just kind of visually draw them kind of with your pencil over top. And if at any point when you draw a vertical line, even if it's only one time, that you hit the graph more than once, you do not have a function. Okay, so vertical line hits more than once, we do not have a function. If I look at this first graph and I try to draw vertical lines, no matter where I draw a vertical line, I'm only touching the graph one time, no matter where I draw. So this is a function. When I try to do that on B, and I draw it here, I hit it twice. If I draw it here, I hit it twice. If I draw it here, I hit it twice. It doesn't matter that if I draw it right here, I only hit once, because at other places on the graph, I have hit it twice. So because I've hit it twice, that means that x value has two different y's, a positive and a negative. So we do not have a function. The next thing we're going to talk about is if we have a one-to-one function, and then this we use the horizontal line test. A function is one-to-one when we have a relation where each y has only one x value. So now we're looking at the other way. In the first pair, when we talked about a function, we couldn't have any y squareds, or in reality, any y to an even power. That's what gives me those two answers. If we are talking about 1 to 1, we don't want any x squareds or x to the fourth, any even power x's. Odd powers are okay. Even powers are not. And I understand that just looking at the function, it may be hard. So easiest way to do that is just graph it and then use either, if you're doing a function, the vertical line test. If you're looking for it to be 1 to 1, check horizontal line test. That's probably the quickest way to do it rather than just looking at the function in written form. So if we look at this first one here, our function is 2x plus 3. We want to know if it is 1 to 1. There is a single x, so yes, we are good. In B, the function is x cubed plus 2. Again, we have a power on the x, but it's an odd power, so we are good. If it was f of x is x squared plus 10, no, this would not be a function. Looking like we did before with the relation here in points, we need to determine whether the function is 1 to 1. So in this time, we're looking to see that y has only one x value. So we got to double check the y's. So 1 is with 0, 2 is with 3, 7 is with 1, 1 is with 4, 5 is with 3. So I see a problem here. 2 is with 3 and 5 is with 3. So a relationship is 1 to 1 if y has only one x with it. Well, the y value of 3 has two different x's with it, so no, this one is not a function. Or sorry, this one is not 1 to 1. Testing 1 to 1, we can draw horizontal lines. And if a horizontal line hits the graph more than once, it is not 1 to 1. This first graph here is an example of a square root graph. And this, no matter where I draw my horizontal lines, I will only hit the graph one time. So it is a function. B, this graph is a cube graph. And anywhere I draw my horizontal lines, I'm only hitting my graph one time. So we are a function. This last graph here is an absolute value graph. And you can see very easily that I will hit the graph 2 times if I do a horizontal line. So it is not 1 to 1. The last part of this section is going to be about function notation. So evaluate a function using function notation, solve a function with function notation, evaluate or solve then those functions from a table or a graph. Function notation is using f of x in place of y. And by having f of x, it is automatically telling you, you have a function and this is what it is. What we are going to do first is evaluate the function for a given x value. So what it shows here in this first problem, it says the function of x is 3x plus 7. Find the value at f of 4. And if I do that, so if f of x, and then I have f of 4, I put the 4 in place of x, that is telling me x is equal to 4. So anytime you see your function notation like this with the number inside of the parentheses, that is telling me plug that value in place of x. So f of 4 means to take 3 times 4 and add 7. Well, 3 times 4 is 12, and 12 plus 7 is 19. Next function of x is x squared minus 10x minus 3, and they want us to find f of negative 1. So f of -1 is going to take -1 squared minus 10 times -1 minus 3. -1 squared is 1. -10 times -1 is positive 10, and then minus 3. 1 plus 10 is 11, minus 3 is 8. And our last one wants us to find f of 3 for the function x squared minus x plus 1. So that's going to be 3 squared minus 3 plus 1. 3 squared is 9, minus 3 plus 1. Well, 9 minus 3 is 6, plus 1 is 7. So that is the first thing that we can do with function notation. These next three problems look a little different. They start the same. They say that given the function f of x equals 4x plus 5, solve f of x equals 29. When they do it like this, f of x, and they give you a number outside of that, what they're asking you for is what x makes the equation equal to that number. So for these problems, when you see here f of x equals this answer, they're asking us solve for x. So what we have to do now is replace f of x with that number. So 29 equals 4x plus 5, and now we're going to solve for x. We do that by getting x by itself. First, we need to subtract 5 from both sides. That gives me 24 equals 4x. And then to get x by itself, I'm going to divide both sides by 4, so x equals 6. So the first problems we did, they gave us x, and we just evaluated. For these ones, they're asking us to find x where we have our answer. So number 5, given a function of x equals x squared plus 4x, solve for x when the equation equals -3. So -3 equals x squared plus 4x. This is one we're going to have to do methods from the previous section. So I'm going to add 3 to both sides, and I have 0 equals x squared plus 4x plus 3. This is a factoring problem because I can find two numbers that multiply to 3, and those same two numbers add to 4. They are 3 and 1. Now, I may find these pairs faster than you, and that's okay. I've been doing this a lot longer, so a lot of these pairs are just quick in my brain. If it takes you a little bit, no worries. Remember, you can always use the quadratic formula as well. So I'm going to factor this into x plus 3 and x plus 1 equals 0. And then I can get my two solutions. 0 equals x plus 3 or 0 equals x plus 1. So if I subtract 3 from both sides, x equals -3 is my first solution. And if I subtract 1 over here, x equals -1 is my second solution. And our last one here, f of x equals the square root of x plus 6. Solve f of x equals 3. So we don't know x, but we know our answer is 3. 3 equals the square root of x plus 6. To get rid of the square root, we are going to square both sides. That makes 9 equals x plus 6. And to get x by itself, I'm going to subtract 6. So I see that x equals 3. We can also evaluate functions from a table, remembering that it's f of x. So if you have the number inside, that's going to come from your x. If it's f of x equals, we're going to look for y equals, or the second column. So given the table below, find f of 1. This is telling me x equals 1. So I find x equals 1, and the answer is -4. B is asking me f of x equals 3. So now I'm going to look in the f of x column for 3. What x gave me that value? Well, x of -1 gives me that value. Let's try the next one. This table is for function g. You may see different letters for the functions, and that's okay. Says g of -1. So this is telling me x is -1. So find x is -1. What is the answer? Well, the answer is 4. For B, it says g of x equals -6. So g of x is -6. So find g of x, find -6. And what gave me that answer was x equals 2. The last way that we can evaluate is with a graph. So given our graph, find g of 2. Well, g of 2 means we have x equals 2 and we want to find the y coordinate. So what's the y coordinate there? Well, x is 2 is over here. The graph is down here. So the point at 2 is at -2. So that means g of 2, if I plug in 2, my answer is -2. Now B, g of x equals -1. So that's like saying I have the y coordinate is -1. What's the x coordinate? So we want to find y is -1 down here. Where does this blue line hit -1? Well, it hits -1 right here. Add the x value of 1. So x equals 1 gives me the answer of -1.